Hey everyone, welcome back to AI Paper Podcasts.
Always good to be back.
Today we're diving into a paper that really flips the script on this bigger is always better idea in AI. You know what I mean?
Yeah.
It's called Reasoning with Latent Thoughts on the Power of Looped Transformers. And it's making waves because it suggests that, well, maybe instead of just building these massive models, we could make them think in loops instead.
Yeah. It's a really intriguing concept.
So for anyone who's new to this whole thing,
Right.
what exactly are these looped transformers that have everyone buzzing?
Okay, so imagine you've got your typical transformer model.
Right.
But instead of having this long sequence of layers, you've got a smaller set that you just repeat over and over.
Okay.
And the information kind of cycles through these layers multiple times, almost like a thought process going in a loop.
So instead of building this giant model, we're saying, hey, let's make a smaller one
Yeah.
and just run the data through it multiple times. That seems incredibly efficient.
It is. And the wild part is that this looping doesn't just save on compute.
Right.
It seems to actually boost the model's reasoning power. The paper shows that these looped models can actually perform as well as much larger models on tasks that need like complex reasoning, even though they're using way fewer parameters.
So we're getting like similar performance, but with way less compute.
Exactly.
That's a game changer, especially with how model sizes have just been, exploding lately.
Yeah, it's a huge deal. And to understand why this looping might be so powerful, they ran some really neat experiments. They tested these models on all sorts of reasoning tasks, from basic arithmetic to, solving actual grade school math problems, things like that.
I'm picturing these models trying to tackle word problems like, if Johnny has 3 apples. It's kind of funny to think about AI thinking in loops like that.
Well, the results are anything but funny, I'll tell you that. The looped models did surprisingly well against much bigger models. In some cases, they even outperformed them.
That's wild. It's like David and Goliath.
Yeah.
But David's got this secret weapon, the power of looping.
Yeah, I like that analogy.
So how do they take this beyond those simpler reasoning tasks and apply it to like the complex world of language?
Well, they trained a 1 billion parameter language model and compared the looped version to the non-looped version on a whole bunch of different tasks.
Okay, so things are about to get really interesting. I can feel it.
They do.
All right, tell me everything.
One of their big findings was that these looped models have this distinct bias towards reasoning.
Interesting.
They were really good at tasks like open book question answering, where they got to find answers within a specific context.
Okay.
But they didn't do as well when it came to pure memorization tasks.
Right, because if you've got fewer parameters,
Exactly.
you just can't store as much information.
Right.
But it sounds like this looping kind of forces the model to think more deeply about the problem to make up for it.
Exactly. And the paper uses this technique called Isoclots.
Oh, yeah, I've heard of those.
To compare the models fairly at the same level of perplexity.
Perplexity, for those who don't know, essentially measures how well a model predicts the next words, like how smoothly it generates text, right?
Exactly.
So are you saying that even when you control for perplexity, the looped models were still better at reasoning?
Yeah, that's exactly what they found.
Okay, now we're getting to the really mind-bending part. The latent thoughts.
Ah, yes.
Can you explain what those are? Because it sounds kind of mysterious.
It is a bit mysterious, and to be honest, we're just starting to understand how they work.
Okay.
But the basic idea is that each loop might be doing more than just processing information in a straightforward way. It could actually be generating multiple latent thoughts.
So like each loop is a mini think tank churning out different perspectives on the data before moving on.
Exactly. And these latent thoughts are like internal representations of the data that aren't directly expressed as words or tokens.
It's more like abstract concepts or ideas that the model is forming in its, mind, so to speak.
Okay, that makes sense. But if these thoughts are hidden, how do we even know they're there?
That's one of the biggest challenges.
Right.
But there are some clues.
Like what?
Well, for one, they found that looped models act a lot like what we see in chain of thought prompting.
Right.
Where we kind of walk the model through a series of reasoning steps.
So it's like those thought tokens we use in chain of thought prompting are giving us a sneak peek into what might be happening inside these looped models.
Yeah, it's like a window into their inner workings.
This is incredible. It's like we're on the verge of a whole new era of AI, where we're not just making models bigger, but actually making them think better.
Absolutely.
This has been eye-opening. It really has.
I'm glad to hear it.
And I can't wait to delve deeper into this, but we're going to have to save that for our next segment.
Yeah, we'll pick it up right where we left off.
Stay tuned, everybody. We'll see you then. All right, so let's dive into how they actually tested these looped models.
Yeah, let's get into the details.
For their language modeling experiments,
Okay.
they used a 1 billion parameter model, and they trained it on this massive data set called the pile.
Right. Pretty standard setup for large language model training, but with the looping twist, of course.
Exactly. And they stuck with that KL notation to describe the different models.
Yeah, that KL, I remember that.
So they tried out different setups,
Okay.
all with this notation K24K,
Okay.
where K is the number of layers in the base model, and 24K is how many times they loop those layers.
So they kept the total depth at 24 layers,
Exactly.
but they were playing around with how many parameters and how much looping to see what worked best.
Yeah, it's a clever way to isolate the impact of the looping itself.
Makes sense. So they weren't just comparing these looped models to any random models, right?
Right. They had some specific baselines.
Okay, what were they?
So first they had a standard 24-layer model with 1 billion parameters.
Right.
And then they had a series of models with fewer layers and fewer parameters.
So one baseline matches the loop models in terms of computational power,
Right.
those FLOPs we were talking about.
Exactly.
And the other one matches them in terms of parameter count, which is basically their memory capacity.
Precisely. So they were comparing against two different things to really see if the looping itself was giving them an edge, you know?
Yeah, that's good experimental design. I like it.
So to really see if the looping itself was giving them an edge,
Uh-huh.
not just having more compute or more parameters.
Smart. So how did they actually measure how well these models perform? Did they just look at Perplexity, or did they, go beyond that?
They went way beyond just Perplexity because, Perplexity only tells part of the story.
Right.
They actually evaluated the models on a whole bunch of downstream tasks, like 4 different categories: closed book question answering, open book question answering, math word problems, and then these things they called reasoning primitives.
Okay. A real test of their abilities.
It was. They wanted to see how they did in all sorts of situations.
Right. Not just how well they could spit out language.
Exactly. And that was really important for understanding the effects of looping.
Yeah, I could see that.
Like closed book question answering is all about memorization, right?
Uh-huh.
Pulling facts out of thin air.
Right.
But open book question answering, that needs more reasoning and inference because they've got to find answers within a given context.
So it's like that classic split between reasoning and memorization.
Exactly.
Okay.
They also threw in the math word problems, which obviously test their math skills.
Yeah, of course.
And then those reasoning primitives were designed to isolate very specific reasoning abilities.
Like really putting them through their paces.
Exactly.
So how do they do?
Well, the looped models, as you might expect, they generally had worse perplexity than the 24-layer baseline.
Okay, makes sense. They had fewer parameters to work with.
Right, fewer parameters means they can't model language as well, usually.
So on that basic language fluency metric, they fell a little short.
Yeah.
But I bet things got more interesting when you looked at those downstream tasks.
You're right. When it came to closed book question answering, the one that relies on memorization,
Yeah.
the looped models did fall behind.
Okay, so in a straight up memory test, looping might not be the best strategy.
Right, but when we moved on to open book question answering,
Huh?
the looped models started to catch up.
Really?
In some cases, they actually beat the 24-layer baseline.
Wow. So even though they couldn't memorize as much, they were better at reasoning through the information they did have.
Exactly.
That's really cool.
And the same thing happened with the math word problems.
Okay.
They held their own against the bigger model, which shows that looping can be really good for mathematical reasoning.
It's really making me question how we measure intelligence in AI.
Yeah.
It's not just about how much you can memorize.
Right.
It's about how well you can think and solve problems.
I agree. And the results on those reasoning primitives, they really drive that point home.
How so?
Well, they consistently beat the 24-layer baseline on those tasks, which were designed to specifically test reasoning, like pure reasoning.
Okay, I'm convinced.
Yeah.
It seems like the looping mechanism is like fundamentally changing how the model processes information,
I think so too.
making it like a more sophisticated thinker.
Yeah.
And that brings us back to the paper's big idea,
Right.
the latent thoughts.
Yeah. The latent thoughts.
Let's dig into that a little more because I'm still a bit fuzzy on how they actually work.
Okay. So picture those looped models again.
Got it.
Information's going round and round through the same layers.
Uh-huh.
Now imagine that in each loop, the model's not just processing things in a straightforward linear way.
Okay.
It's actually generating multiple latent thought.
Like each loop is a brainstorming session where the model explores different interpretations of the data.
Yeah, something like that. And these latent thoughts, they're like internal representations that aren't expressed as, as words or tokens. They're more like abstract concepts that the model's forming in its own, mind, so to speak.
Right. But if they're hidden, how do we even know they're there? It feels like we're just taking their word for it.
It is tricky to study them, and the paper admits that. They do offer some evidence.
Okay, I'm listening.
They saw that the looped models act a lot like what we see in chain of thought prompting,
Right.
where we kind of guide the model through its thinking.
Yeah.
So it's like those thought tokens we use in chain of thought prompting are giving us a peek into the kinds of latent thoughts that might be happening in the looped models naturally, precisely.
Wow.
And they actually developed a mathematical framework to explain how looped models can simulate chain of thought reasoning. So, it's still early days for that kind of theoretical analysis,
Sure.
but it does suggest that there's something special happening in those loops.
This is really fascinating.
It is.
It's like this paper is pushing the boundaries of what we thought was possible with AI.
Absolutely.
It's not just about making models bigger anymore, it's about making them smarter.
Right. We're not just engineers building machines anymore.
Yeah.
We're like, we're architects of intelligence.
I love that.
And we have a responsibility to make sure that intelligence benefits everyone.
Absolutely. Before we get too carried away with all the possibilities,
Yeah.
we should remember that this research is still pretty new.
You're right.
There's still a lot of questions and challenges ahead.
Definitely. We need to be careful and critical and, think about the ethics of all this.
Exactly. As we build these increasingly intelligent systems,
Right.
we need to make sure they align with human values.
Well said.
Okay, so before we move on,
Yeah.
I want to touch on one more thing from this paper.
Right.
The idea of inductive bias. I've heard the term, but I'm not totally sure I get it.
It's basically about the assumptions a model makes about the world, which guide how it learns.
So like preconceived notions that can either help or hurt its learning.
Exactly. And what's cool about this research is that it suggests that looping might actually give models a bias towards reasoning.
Wait, so the architecture of the model
Yeah.
can actually influence what it learns and what it's good at. That's amazing.
It is. And to explore this further, they went back to those isoclots we talked about.
The ones that compare models at the same level of perplexity, right?
Right. And what they found was pretty remarkable.
Okay, tell me everything. Okay, so inductive bias, right? It's this idea that a model's architecture can actually make it better at learning certain things. Did this paper actually find that looping makes models better at reasoning?
That's right. Yeah, that's what those isoplots were all about. Remember, those plots let the researchers compare models that have, the same perplexity, so it's a
Yeah.
fair comparison.
Right. And what they found is for tasks that are all about memorization,
Okay.
looped and non-looped models perform pretty much the same.
So for those memory-heavy tasks, looping didn't really make a difference.
Not really, no.
But I have a feeling that's going to change when we start talking about the reasoning tasks.
You got it.
Okay, tell me.
When they looked at open book question answering
Yeah.
and those reasoning primitives we talked about,
Yeah.
the looped models, they consistently did better than the non-looped models, even when they had the same perplexity.
So even when you control for how good they are at language, just basic fluency,
Right.
the looped models are still better at reasoning. That's wild.
Yeah, it's strong evidence for that inductive bias towards reasoning.
It's like having two students who, they both have the same vocabulary, they both know the grammar, but one of them is just naturally better at solving logic puzzles,
Yeah, exactly.
And for the looped models, that knack seems to come from the looping itself.
I think so, yeah. It's crazy to think that the structure of the model can actually affect how it thinks, like its actual cognitive ability.
I know, it's pretty mind-blowing.
It makes you wonder if looping can create this bias towards reasoning, could we design other architectures
Yeah.
that create biases towards other things like, creativity or empathy or even common sense.
I think so, yeah, absolutely. That's a whole new area of research that's just waiting to be explored.
It's like we're not just building AI models anymore. We're like shaping minds.
Yeah.
We're like sculpting their abilities through the architectures we choose.
That's a great way to put it.
So this paper takes it even a step further, right?
Yeah.
They found that you can actually transfer this bias towards reasoning
Right.
without even using loops.
Yeah.
How is that even possible?
They did it using something they called looping-inspired regularization.
Okay.
Basically, they added a new term to their training process that encouraged the weights of the different layers to be more similar to each other.
So they were kind of tricking the model into acting like it was looped, even though it wasn't.
Pretty much, yeah.
That's so clever. And did it work?
It did. They saw better reasoning skills without messing up the perplexity too much.
So it's like getting the benefits of looping without actually having to loop.
Exactly. It's like a free lunch.
This whole concept of inductive bias and how we can like manipulate it is just, it's so exciting.
I agree.
It's like we're cracking the code of intelligence.
Yeah, it's like a whole new language for shaping AI.
This paper has really changed how I think about AI, you know?
Yeah.
It's not just about building bigger models anymore.
Right.
It's about understanding the fundamentals of intelligence
Yeah.
and figuring out how to put those into our systems.
Exactly.
Well, this has been a fantastic deep dive.
It has.
I've learned so much,
Me too.
and I'm sure our listeners have too.
I hope so.
Thanks for joining us, everyone.
Thanks for having me.
And until next time, keep exploring, keep questioning, and keep pushing the boundaries of AI.